Hey everyone, today we are solving LeetCode problem number 576 out of boundary paths. It is another important question and has been asked in Amazon and Baidu. Let's have a look on the problem statement. In this question, there is an M cross N grid with a ball, and the ball is initially placed at the position start row and start column. This is the initial position of the ball in the grid, and this is the grid size. And you are allowed to move the ball to one of the four adjacent cells in the grid. And in the grid, the ball can move these four directions: right, left, top, bottom. And you can apply at most max move moves to the ball. So the direction the ball can move is these four direction, and we can apply at most this number of moves to our ball. So these are the five variables given to us: m, n, max move, and starting position, starting row and starting column. And we have to return the number of paths to move to the ball out of the grid boundary. Since the answer can be too large, it should be modulo of 10 to the power 9 plus 7. So now let's try to understand it using this example here. M cross n. This is the size of the grid. That is, it is 2 cross 2 size grid, 2 column and 2 row. This is max move variable. It means that the ball will move these number of times only. And in one step, the ball can move in four directions: right, left, up, down. And this is the starting position of the ball, starting row and starting column. Here the ball is placed 0 0. Now if we try to move, and we have to give find the number of ways to move this ball out of the boundary. And this is the boundary, this is the boundary of the grid, and we have to move this ball and make it out of the boundary within max moves, number of moves. Okay, let's say if I make one move upside, it is going out of boundary. If I make one move left side, it is going out of boundary. And if I make one move down or one move right, it is not going out of boundary. And further to these, if I make moves, now we have already made one move to down, we can make one more move. One more move can be this side or this side. So here also we have already made one move, and the one another move can be up, right, and down. And if we make left side, it won't be out of boundary. So we only have to capture the path where it is taking at most max move steps, and it is going out of boundary. So here if you see this, these paths are making the ball out of boundary. This and these steps are not making it out of boundary. So in total 1 2 3 4 5 6, in total we have 6 paths where this ball is moving as per the given statement, given condition, and it is crossing the boundary within max moves. Max moves were 2 here. I hope the problem statement is clear to you. Now let's move to the approach. Let's have a closer look to this example again. We were having 2 cross 2 grid, and our ball was placed at 0 0, and we were allowed to make two moves. Maximum move, let's call it capital M. Maximum moves were 2. So if I make one move here, one move here, these 4 moves, these moves are making it crossing the boundary. And in further moves, we are allowed to make 4 more calls: up, right, bottom, or left. Left call is useless. Right, bottom, left, and up. So here we are again making 4 calls. So if I zoom out this section, we are having a grid, and ball is placed here, and we have to make it out of boundary where capital M is 1, because we have already utilized one step here. Initially it was M equal to 2, now M equal to 1, and we have to make it out of boundary within this m cross n grid, and it was initially at 0, 1. In the above case it was at 0, 0. So if you like see it as a sub problem of this question, it's totally the same. That in this problem also we are having 5 variable m cross n, and the maximum moves is updated, I is updated, j is updated. I is actually same, but the set of ij is updated. So this is our sub problem. So in this sub problem, m value is reduced. So if we keep on reducing the m value, or if we are moving to the boundary, we have to terminate our recursion. If we have reached to the boundary, it means it is a valid path. If the m value is 0 or negative, we have to close the recursion call. So using this intuition, I got to know that this is a recursive solution and we have to write a recursive solution for that. Let's code it recursively. Let's say in the solution function, we are getting 5 variables, small m, small n, which is the boundary or maybe a dimension of grid. Let's say we have capital M. M is the number of moves, which was 2 in the previous example. Apart from that, we have our initial position, which was 0 in the above example. Okay, so this is my solution function, and here what I will do is I need to check whether I am reaching the boundary, or I'm left with no m variable, or maybe like I have utilized all the value of m, that is our allowed moves. Let's say if at any instant I will check for the value of I and j. If ij crossing boundary, it means that is a valid path. In that case I can return 1 integer, and if m equal to 0, I will return 0. This you can call pruning, because it is of no use to keep moving ahead. And this is the terminating case. And now what is the next part? Move in all the 4 direction. So for that, let's call it d. D is the direction, and direction is the direction array where I will store all the direction. Let's say initially one unit moving in the x direction, minus 1 unit in the y direction, and sorry, minus 1 in x direction, and 0, 1 unit up direction. So this is up, this is right, this is bottom, this is left. So covering all the 4 direction. And what I will do is I will make subcode with m and m minus 1. I have utilized one move, and the next updated value is I plus d of 0, j plus d of 1. This is next ij, and here I have utilized one move. So now when it will come to this end, it will see whether we have a valid ij or we have crossed the limit, crossed the boundary. If we have crossed the boundary, it means that this path is taking less than or equal to m moves and it is crossing the boundary. It means we have to capture this path. And if m is equal to 0, we have utilized all of our allowed moves. In that case, we will return 0. And ultimately, we have to like check recursively and store our answer plus equal to this. And before that, I will also take my answer variable. And after this call, after this for loop, I can directly return my answer. So this is the basic skeleton for this recursion. And here there comes a couple of more points. First of all, I have to take modulo of 10 to the power 9 plus 7. So while capturing the value, I will keep on taking the modulo equal to m. I will be taking the modulus. And apart from that, our solution function m and capital M I j is dependent on these three values. It means at any instant of the call, these three values can get repeated in our overlapping subproblems, because it is possible that we are moving to the same value of ij after some after different permutation where we have similar value of m. So the combined set of these three value will get repeated among our solution, among our recursion calls. So we have to memorize these value as well. So for that, what I can do is I can directly take 3D array, and the value of I, J and capital M are going till 50 as per the constraints in the problem statement. Okay, so first of all I will write the recursion solution of that, and then we can memorize it by taking a 3D array. Okay, now let's try to code this approach. And here, what is the time complexity? Time complexity would be like m cross n and into m, maximum number of moves, order of m into n, and the maximum number of moves allowed to us. This will be the time complexity after we have done the memorization. After memo, this is the time complexity. Okay, now let's try to quick code this problem. Let's start writing the code for that. First of all, I will write a helper function where I will pass all these variables m not int, solution m comma n. These are the constant grid dimensions, maximum move, start row and start column, and I will be returning int from it. So private int solution int m int n, let's say int m is the maximum moves, int I int j for starting position at any call. First of all, we will check whether the ij position is crossing the boundary or not. If I is less than 0 or j is less than 0 or I is equal to m or j is equal to n, it means we have crossed the boundary. It means we will be returning 1 from here. If m is equal to 0, it means we are left with no moves. So we cannot complete this path and we have to return 0. That it means that this path will not contribute to our answer, and this is one valid path. And now we have to move in all four direction for integer array dir. I'm taking a global variable to store my directions. New int 1 comma 0 0 comma minus 1 0 comma 1 0 comma minus 1. These are the four direction where I can move 1 0 0 minus 1 0 1 or minus 1. It should be minus 1 and 0. Now it is covering all the four directions. And here I will make a solution call again with m comma n, and I have utilized one move I plus d0 and j plus d1. This ij is my next position and I have utilized one path. So whatever answer I will get, I will be adding to my global answer. And int answer equal to 0. Here I can directly return my answer. Let me try to submit it. This is the native recursion to solve this problem. Okay, this recursion is submitted, but it will be having a load of overlapping subproblems over m, I, j value. So even if I submit this problem, I will get TLE or maybe wrong answer because I have also not taken modulo. So here it is TLE. So to get rid of the TLE, I will also memorize my solution for integer array. dp is equal to new. I will go after constraints. Constraints are till 50, so let's keep it 51. And here, before returning the answer, I will store it against the value of I, J, and capital M. As here I am storing my processing, so before starting the processing, I will check whether we have already cached the answer or not. If that value is not equal to null, we can directly return this value. Otherwise, process it. And I'm using a wrapper integer class, so it will also be initialized with the null in the starting. Okay, memorization is also done. Now the time complexity would be m into n into capital M. So here I forgot to take a modulo. Answer modulo equal to mode. Let's take a separate variable for mode as well. Mode equal to 1 2 3 4 5 6 7 8 9 plus 7 times 5 9 plus 7. Okay, now try to submit it again. Our sample cases. On the sample cases it is passed. Submitting the problem, it is submitted successfully. Hope you understood the problem. Thank you guys. Here we did the recursion with memorization, so it's another standard dynamic programming problem.